Hello everyone. So today in this video we are going to solve a question of LeetCode, that is last stone weight. This is 1046 question on LeetCode and this comes under easy category. Alright, so let's start with the problem statement. You are given an array of integer stones where stone I is the weight of ith stone. You are playing a game with the stones. On each turn we choose the heaviest two stone and smash them together. Suppose the heaviest two stone have weight x and y, where x is less than equal to y. The result of this smash is x. Like there are two conditions. If both the weight of the stones are equal, then both the stones are destroyed. If the weight of both the stones are not equal, then the stone of weight 8x is destroyed and the stone of weight y has a new weight y minus x. So basically the stone with lesser weight, or we can say, like in this condition we have taken x is less than equal to y. So if second case is true, that is both are not equal, so x is definitely less than y. So the stone with lesser weight is destroyed and the stone with heavier weight is updated with the weight y minus x. Alright. So these are the two conditions which we need to check in each iteration, and at the end of the game there is at most one stone left. Return the smallest possible weight of the left stone. If there is no stone left, return 0. Alright, so let's take the first example. In the first example, we have 274181. So let me take this example here. So in the first example, we have 274181. So let's choose x and y. Alright, so x is equal to 1, y is equal to. Now let's choose x and y in this array. So x and y we need to choose such that both the stones are heaviest in the array. So the heaviest in the array, and we need to choose the such that x is less than equal to y. Alright, so let's choose the two heaviest stones in this array is 7 and 8, and we need to choose such that x is less than y. So x will be 7 and y will be 8. Now we need to check two conditions. If both are equal, then both the stones are destroyed. In this case, both are not equal. Then second condition is true, that is x is not equal to y. So the stone of weight x is destroyed and the stone of weight y has new weight x minus y minus x. So this stone is destroyed and y will be updated to y minus x, that is 1. Alright, so 8 is updated to 1 and 7 is destroyed now. Now let's check for other conditions. Now at this point of time there are two heaviest stone in this array, that is 2 and 4. So let's update x to 2 and y to 4. Now the second condition is again true, so let's destroy x and update y to 4 minus 2, that is 2. So let's destroy 2 from here and update 4 to 2. Now let's check the two heaviest stones again. So two heaviest stone is 2 and 1. So let's update x to 1 and y to 2. Now again the second condition is true. So let's destroy x and update y to x minus y minus x. So 2 minus 1 is equal to 1. So let's destroy 1 from here and update 2 to 1. Now let's check in the remaining array. Now the two heaviest stones are 1 and 1. So let's update x and y to 1 and 1. Now the first condition is true, that is both are equal. So both the stones are destroyed. So let's destroy both the stones from here, and at the end only one stone is remaining in the array. When one stone is remaining in the array, let's directly return that stone. Alright, so I hope the approach is clear to you. So let's quickly code it up. This is basically like we need to check the two heaviest stones. So to check the heaviest stone, the approach which we are going to use here, we will be using a priority queue. Priority queue is a type of data structure which store the heaviest element, or we can say the largest or greatest element at the top of its queue. Alright, so let's take a small example here again, and we will be understanding how can we use a priority queue here. Alright, so let's take, we are taking the same example again, and x and y are same. Alright, so let me make a priority queue here. So what will happen in the priority queue, it will always give the topmost element as the greatest element. Alright, so let's say we are taking x as the topmost element. So topmost element would be 8 because it is greatest in the array. So x will be 8 and y will be equal to, let's say it is 7. So it's 7. Let me just interchange x and y because according to quotient that is given, x is less than equal to y. So let's just interchange both of them. So this will be x and this will be y. Alright, so let me just code simultaneously so it would be more clear to you. So what we will be doing, we will be making a priority queue here. So let's make priority queue here of integers and let me name it q, and let's update the element. Let's add the element of stones array in this priority queue. So stones dot begin and stones dot end. Alright, now what we will be doing in each iteration, we will be checking the two topmost element. Alright, so let's run a while loop until q dot size is greater than 1, because at the end at most one stone must be there. Alright, so let's keep a element into the queue. Alright, so what we will be checking here is, let's take two integers int y is equal to q dot top. We are taking y first because the condition here is that x is less than equal to y, so y must be greater here. So q dot top, and let's pop it out from the queue, and let's take another element int x is equal to q dot top and q dot pop. Now let's check if x is does not equal to y, then we will be updating y to y minus x, and let's push it into our let's update y to y minus x, and let's push it into our q. So q dot push y. Alright, so at the end what we will be doing, we will be returning if q dot size is equal to 1, then we will be returning q dot top, otherwise we will be returning 0 as it is given. The smallest weight we need to return from here. If no stone is left, then we will return 0. So this is we are returning here. So let's just run it. Yeah, it's working fine. So what we are basically doing here is that we are taking two elements y and x as a topmost element, because let's say we have taken y here. So this in this statement y will be such that it is the greatest element, or we can say the heaviest stone in this array. So let's say we have taken the topmost element of the queue, it is 8. Now the 8 is popped out from here. Now in the second statement, x will be equal to the topmost element. So in this again, it will be returning the greatest element out of this array. So greatest element is 7. So 7 is popped again. So x and y will be such that the greatest element. Now x and y is not equal, so y will be updated to 8 minus 7, that will be equal to 1. Now 1 is again pushed into our queue, so 1 will be again pushed in the array. Alright, so similarly this loop will go again and again until q dot size is greater than 0. At the end, q size will be equal to 0, as we have seen few minutes earlier. So at the end, the array will become something like this, or we can say q will become something like this, and this will come to this return statement and it will return 1 from here. Alright, so I hope the approach is clear to you. It's running fine. Let's just submit it. It's fine. So let's calculate the time and space complexity of our solution. So the time complexity of our solution is big O of n log of n, because priority queue takes around n log n time complexity as it is sorting the vector internally, and space complexity of our solution is big O of n because we are storing all the n elements into our queue and it is taking extra space here. So I hope the approach is clear to you and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video, subscribe to our channel. Thank you.